will not be any confusion. So what is the sorted list? 6, 7 has weight 1, then 5, 6 has weight 2, then 2, 8 has weight 2, then 0, 1 has weight 4, then 2, 5 has weight 4, then 6, 8 has weight 6, then 2, 3 has weight 7, then 7, 8 has weight 7, then 1, 2 has weight 8, then 0, 7 has weight 8, then 3, 4 has weight 9, then 4, 5 has weight 10, then 1, 7 has weight 11, and the last age is 3, 5, which has weight 14. So that is the complete, that is the complete list. That is the complete sorted list of ages. Now what we will do, we will add the ages so that there will not be any cycle in that spanning tree. So how to find out that whether there is no cycle while adding an age? So for that we will use the concept of disjoint subsets. Two sets are called disjoint sets if they don't have any common element. So we have to construct disjoint subsets in such a subset. So using the concept of disjoint subset, we can confirm that whether there can be any cycle or not. So first of all, so how to find out whether we will go on, we will start from the least weighted ages and we will go on adding the ages according to their increasing weight. But the concept, we have to consider here one question, that is, if that age, if we consider an age which after that creates a cycle, then that will not be added, that age will not be added, that will be discarded, and we will go for the next higher weighted age. So that is the consideration while going on adding the age according to that sorted list. Why we have written that sorted list? Because we have sorted according to increasing order, so that we will start from the least weight and we'll go on adding. So that if we start from the list and go on adding the next higher weighted age in this way, so the total cost will be minimum. So here the concept is that we will add that age only when there will not be any cycle. So how to find out whether adding that age that will not create a cycle? So for that, a particular algorithm we will follow, which is called fine union algorithm. So what is that? I will tell that. But before that, I want to just write all of the vertices, because spanning tree will contain all the vertices of the graph. Only the number of edges will be listed here. So we have to choose which edge to be added or not to the tree. So first we are drawing the vertex. It is 0, 1, 2, 3, 4, 5, 6, 7, 8. And first we will consider the age 6 and 7, which has weight 1. But while considering every age, we have to check whether adding that age on the tree, no cycle will be created. So for that, what we will do, we will divide the set of vertices into the disjoint subsets, and each of the subsets will contain only one vertex only. So as there are 9 vertices, so there will be 9 subsets of vertices, where each vertex will be in each subset. So what are those sets are now disjoint subsets of vertices. 0 is in one set, 1 is in another set, then 2 is in another set, but each vertex is in one different set initially. So that is required to find out whether a cycle is created or not. So 4, 5, 6 is another set, 7 and 8. These are all the disjoint subsets of vertices. Disjoint means they don't have any elements common. Between any two sets, there are no elements common. Now, if we add 6, 7, we have to find out whether this vertex connecting the edges. These two vertices are in two different subsets or not. Say 6 in this set and 7 is in another set. That means if we go on adding this 8, 6, 7, that will not create any cycle. So what we will do, we will go on adding this 8, 6, 7. So we add message and its weight is less, its weight is 1. So after adding this 8, 6, 7, which how we find out, because it belongs to two different sets. 6 and these two vertices are in two different sets. So after adding this 8, we will merge this two set. That is, we will do union of this two set. So now the disjoint subsets will be 0, then 1, then 2, then 3, then 4, then 5. Then 6 and 7 will be merged into one set. 6 and 7 will be in one set. Then 8 will be in different set. Next minimum weighted age that is to be considered here will be 5, 6. Now I have to check whether this age, if we add this age, whether any cycle will be created or not. For that we have to see this disjoint subset. See 5 in this subset and 6 is in different set. So if we go on adding this age 5, 6, that will not create any cycle. So we'll go on adding this age 5, 6. So what I am doing, I am adding this age 5, 6, and after adding these two different subsets which contain the two end vertices of the edges in two different sets, that will be merged together. So the disjoint subsets will be 0 is in one set, 1 is another, 2 is another set, 3 is in one other, 4 is another. Now 5, 6 and 7, they will be merged, and 8 is in another subset. Next higher weighted vertex is 2, 8. So first I have to check whether vertex 2 and 8 are in two different sets or not. 2 is in this set and 3, 8 is in this set. So they are on two different sets. So if we add on this age, no cycle will be created. So we go on adding this age to 8. So we add this age to 8 and his weight is the next higher weight, which is 2. And in this disjoint subset, this 2 and 8, these two sets will be merged into one set. So what will be the disjoint sets now? 0, 1 in different sets, and 2 and 8 is merged into one set. Then 3 is another set, and 5, 6, 7 is in another set. See, we are going creating only the disjoint subsets in this way. Then the next higher weighted age is 0, 1. Now we have to consider whether vertex 0 and 1 are in two different sets. Yes, 0 is in one set and 1 is in another set. So if we add on this age 0, 1, it will not create any cycle. So we will go on adding this age. So we add this age 0, 1 and the weight is 4. And what we will do, we will merge these two subsets, and after merging they will be in one set. So 0 and 1, what are the disjoint subsets now? 0, 1 is in one set, 2, 8 is in another set, 3 is in another set, 4 is on another set, and 5, 6, 7, these are on another set. Next, our higher weighted age is 2, 5. Now I have to check whether vertex 2 and 5 are in two different sets or not. Yes, 2 is in this set and 5 is in another set. So if we go on adding this age, this will not create a cycle. So we go on adding this age 2, 5, which has the weight 4. And these two sets, 2, 8 and 5, 6, 7, they will be merged together. So the set will be 0, 1, then 2, 5, 6, 7, 8 is in one set, then 3 is in another set, and 4 is another set. So now these are the disjoint subsets of the vertices. Okay, then the next vertex is 6, 8. The next stage is 6, 8. Now we have to check whether adding 6, 8, any cycle will be created or not. These 6 and 8 both are in this set. So So if we add 6, 8 this age, then cycle will be created because their both vertices are in the same set. That means they will create a cycle. So we will not add this 8, 6, 8. Rather, we will discard this age and we will go for the next higher weighted age, which is 2, 3. Now vertex 2 is in this set and vertex 3 is in another set. So if we go on adding this age 2, 3, no cycle will be created. So we add age 2, 3, whose weight is 7. So what will be the disjoint subset now? 0 and 1 is in one set. And this set 2, 5, 6, 7, 8 and here 3, they will be added, they will be merged into one set. So 2, 3, 5, 6, 7, 8 is in one set and 4 is in different set. Next what age will be considered? Next high weighted age is here, which is 7, 8. 8, 7, 8, whose weight is 7. Okay. Okay, now I have to check if we add this 8, 7, 8, whether any cycle will be created or not. Now see, vertex 7 and 8. These are two vertices, they belong to the same set. So if we go on adding this age, then cycle will be created. So we will not add this age, we will discard this age and we will go for the next age in the sorted list, which is 1, 2. Now if vertex 1 is in this set and vertex 2 is in another set, so if we go on adding this age 1, 2, no cycle will be created. So what we will do, we will add this age 1, 2. So we'll add this age 1, 2, whose weight is 8. And what will be the change in this disjoint subset? This 0, 1 and 2, 3, 5, 6, 7, 8, they will be merged together into one set. So it will be 0, 1, 2, 3, 5, 6, 7, 8 and 4 is in on different set. Next higher weighted vertex is 0, 7. Now if we see that both vertices 0 and 7 are in the same set, so if we go on adding this age, then there will be cycle created. So we should not add this age, we discard this age and we will go for the next age, next higher weighted age, which is 3, 4. Now consider 3, which is in this set, and 4, another vertex which is in different set. So if we go on adding this age 3, 4, cycle won't be created because they are on the two different disjoint sets. So we go on adding this age 3, 4, whose weight is 9, and the vertex will be now this set and this set, there will be merged. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Then there contains only one set of vertices. Now if we check what is the total number of edges in the spanning tree? 1, 2, 3, 4, 5, 6, 7, 8. Exactly, I told you in spanning tree, if there are 9 vertices, so the number of edges will be 9 minus 1, which is 8. So exactly we have added 8 edges in that spanning tree, and there is no cycle, and we have added 8 edges, so our algorithm stops here. Now what is the cost of the spanning tree? That means we have to add on every the weight of every edges in the spanning tree, and then the total width will be the cost, and that will be the minimum cost spanning tree. So if we so what is the total cost of the spanning tree? So that will be this we go on adding the weight 1 plus 2 plus 2, then 4, then 4, then 7, then plus 8 plus 9. So what is this? So what is your summation? 2, 5, 9, 13, 20, 28, then 37. So what is the total cost of the minimum spanning tree? That is at 37. That means if the spanning tree can be constructed, there can be constructed so many spanning trees, but this spanning tree has the minimum cost among all other spanning trees. So that's why this is called the minimum cost spanning tree. So we have constructed the minimum cost spanning trees according to Kruskal's algorithm. According to Kruskal's algorithm. So that is the total step that I first of all what we did, we just sort we just in minimum cost spanning tree. First we sort the edges according to non-decreasing order, because we will go through the list from least weight to the maximum weight, and in this way, while we are starting from the least weight, and then when the total all edges will be added in that way, then the total cost will be minimum. So first step is sorting. Then after sorting, just go through adding on edges starting from the least weighted edge, and if if on adding that edge no cycle is created. How to find out? That is, we have to form this disjoint subsets of vertices, and by constructing this disjoint subsets of vertices, we can find out whether adding any edge it will be creating any cycle or not. If an adding on edge, we can find out that no cycle is created, no cycle will be created while adding this edge in the spanning tree. Then only we add that edge. Otherwise, we will discard it, and we will go considering for the next higher weighted edge in the list. So in this way, the minimum cost spanning trees has been constructed according to Kruskal algorithm. Okay, thank you.